All right, today we are going to look at Lesson 9.1, Inequalities. An inequality looks like this. We're talking about something that's not equal to something else. So, for example, he is less than 8 years old. We don't know how old he is. We do know that he is less than 8 years old. So how do we write that? We would write it like this. His age, that's going to be our variable, is less than, we use a less than symbol, 8 years old. So we just go x is less than 8. Now, the difference is from the equations is we have a whole range of possible solutions here. X could be 7, 6, 5, 4, 3, 2, 1, 0, right? So we got to be able to graph that. So we've got our graph. Number line should technically have arrows on the ends because these could go on forever in each direction. And now, less than symbol would be an open circle on top of my 8 here. And then if it is less than, what numbers are less than 8? Well, 7 are less than 8. So we shade in to the left side. So that means everything over here could be part of my solution here. Now we go down to the next one. The number that we're looking for in this case is no more than -4. So how do we write that? The number, our variable, is no more than -4. Okay, well if it cannot be more than, then that means this number can't be more than. That means it has to be less than or equals to. Okay, because it can't be more than. That means it has to be less than, but it could also be equals to. Now, if it's equals to, what does that mean? That means that instead of an open circle now on the 4, the -4, this -4 could also be part of my solution. So we got to shade it in, because it could be everything less than -4 or also equals to -4. So now we shade in everything that is less than 4, but also equal to -4. That's why it's shaded in on this one. Whereas if we go back up here, you can see that everything less than 8 was part of my solution, but 8 was not. That's why it was left open. And so now we go down here. You ate at least 5 cookies this morning. So how do we write that? Well, you ate, we don't know how many you ate though, do we? That's x. But we do know you ate at least 5 cookies. So what symbol can represent at least? Well, that means you could have eaten more than 5 cookies, correct? Because the least number of cookies you ate was 5. So that means it could also be equals to. So more than, but also equals to. Or equals to, I guess. So it's x is greater than or equals to when you see the at least terminology. So once again, it could also be equals to the 5, so we got to close in that circle. Anytime you got or equals to, then that means the number could also be part of my solution. And x is greater than 5 this time, so we're going to shade in everything that is greater than. Don't forget your arrows, because those go on forever, right? All right, so now that's just your basic identifying what it means when you're translating a phrase into a basic inequality and then how to graph it. Well, what does that mean then when I have to solve these inequalities? Well, what I've got here is 2 basic inequalities using addition and subtraction. And we solve these just like as if this was an equal symbol right here. Okay, if this was an equal symbol right here, I would make a t-chart, and I would have to balance this equation, right? Subtract 17 on both sides. Well, I do it the same way. Let's go back up here, change this back to, what symbol was it? Greater than symbol, doesn't matter. You still make your t-chart, and we get rid of the positive 17 by subtracting 17. So we got x is greater than, what is 7 minus 17? leaves me with negative 10. So now we solve this using a one-step solution, using the opposite of the 17 to cancel it out. Hello, you just interrupted my video.